This is Computing Up, conversations about computation writ large with Michael Littman and Dave Ackley. This episode was recorded November 1st, 2021.
Today we have with us Carla Brodley, who has been many things. I will tell you her current title, at least according to the website: Professor, Dean of Inclusive Computing, Northeastern University, Executive Director, Center for Inclusive Computing. And I've known Carla since she was just a plain old professor, as my friend Charles likes to say, and when she was dean of her college. And now she's got this new role, and I'm really excited to hear more about what she's been up to in that role. Carla, if you don't know her or don't know her by reputation, is a very significant contributor to the field of machine learning, but she has shifted into working in academic administration as well, and trying to make computing a better place, meaning better for the people, and also better, like the things that we produce would be better, I think, as a result of that. So very excited to have Carla on the show. Hi, Carla.
Hi, happy to be here.
That's great. Yeah. And so now I kind of thought that you and Dave already knew each other, but I'll tell you why, because I don't think you do. The reason that I thought that is because is that you had Heather Lane in common.
Right.
Heather, previously Taryn Lane. And because Dave worked with Heather very closely at UNM, or at least they were in the same department together, and Carla and Heather worked together as well. Yes?
Heather was my PhD student.
Exactly.
My second PhD student.
Nice.
Oh, wow. How many PhD students have you had all told at this point?
14.
Wow.
There you go. All right. So very early on. And as I recall, you guys, so you're in machine learning, but a lot of the work was was computer security related. Is that right?
Correct. I was at Purdue University, which is well known for its expertise in cybersecurity. And I got really interested, and Heather and I, Taryn at the time, worked together on applying machine learning to various aspects of cybersecurity.
That's awesome. So can you give us like a bullet on like, what did you guys find out? I definitely have been asked by cybersecurity people to help out, and I always feel like, I don't know what tools for machine learning really could be helpful here. So you guys found a way to make some interesting connections there. What
we worked on was, could you tell who someone was based on the sequence of commands that they use? And
so it's like a biometric sort of thing.
It was a biometric. It was for insider threat. Mm-hmm. So somebody leaves their laptop or their computer open, they go off to do something, somebody else gets in and starts doing things on it. How quickly can you tell that it's actually not them?
Super interesting.
Wow.
Well,
so I mean, I thought about that back in the 90s, I guess.
It was the 90s.
Right. And even did a little work with an undergrad. And I saw when I was looking at your CV that you actually had a paper on exactly this, with identifying mouse movements as whether it was, characteristic of the correct user or not. And we went down that road a little bit, and it seemed like it was super hard. But you guys managed to have some success. Is that what I'm understanding?
Yeah, and that was with another PhD student, Maya Pazara. And what we found was that if we had a profile of how you move your mouse movements, we could detect whether or not it was you really, really quickly. Wow. And then I had a little fun project where we decided to apply this. Could you tell if the driver of a car was the person who normally drives the car or not?
That's
because
great.
This was back after 9/11, and we were thinking about if someone hijacked a truck that had bad stuff on it. And what was really interesting is we looked at acceleration and deacceleration patterns. And it turns out that acceleration patterns are a function of the car in front of you, and deacceleration patterns are the ones that are predictive. And so the student I worked with, we created this loop that you would drive, and each person in the lab did it, 5 or 6 times. So he would have enough training data. And he came back after going on this experience with one of my students from Turkey and said, I will never get in a car with him again. Because he managed to do the loop in half the time the rest of us did it in.
And didn't even crash once.
This time. Yikes. Yeah, I had heard stories about of self-driving car researchers basically not, once the car is trained to act like them, that the other drivers don't want to be in the car anymore. People like the way they drive, but they don't really like the way that other people drive. It's uncomfortable.
That's
super interesting. And Dave, you thought a bit about computer security in the context of cars as well, yeah?
Geez, cars. What am I thinking about?
Well, I was thinking your story where people break into the cars at the, I don't know, like the Super Bowl or something like that. And then make a big mess of things.
Sure. Yes. Well, I mean, so let me back up one sec. I mean, so, I saw that you had gotten some computer security stuff in your research history, Carla, but it didn't seem like you were working on it so much lately. And, that's kind of my history as well. I spent a decade or so trying to work. I mean, in my case, it was on adaptive system approaches to computer security one way or another. And I kind of got to a point of despair that as far as actually making computer, or solving computer security or really even making things much better, I wasn't sure that it was possible. And is your experience anything like that, or you just moved on to other stuff because of whatever?
No, I mean, what happened is that I left Purdue University and joined Tufts University, and there weren't the computer systems faculty to work with. And you really need your students to be trained in all aspects of networking, operating systems, compilers, programming language. Yeah. So when I moved to Tufts, I thought, well, I'm at a really good medical school, so I think I'll focus. Basically, what's been throughout my career is the desire to apply machine learning to solve real problems. I want to say one thing about cybersecurity, though, Dave, which is, as a dean, it's one of the areas that I focused on building the faculty. We had an Institute of Cybersecurity and Privacy. We created an undergraduate degree in cybersecurity. We became part of the Cyber Core program at the National Science Foundation. And I firmly believe that there's things that you can do to help with cybersecurity, but that it's always going to be an arms race.
That it's not something that we're actually going to solve. We're just going to manage, mitigate.
Correct.
Like that, yeah. And well, I hope so. I mean, it's a whole different conversation about is there another computer architecture that we could do that would be structurally better than what we're doing now. But the point is, we're doing what we're doing now, so we got to live with it no matter what. But yeah, I mean, I saw you have a bunch of papers about medical machine learning of medical stuff and all of that stuff. I mean, that it seems like both full of potential and also got its own set of risks, kind of like computer security does.
Yeah, I mean, yes, absolutely. And although some of the work that I'm most proud of is work that I did in the medical field, and in particular, things that I worked on with various groups that actually made it into clinical care, and that I cared deeply about.
Wow, that's great.
So we've kind of had little visits on a couple of your affiliations. So we mentioned Purdue and Tufts and Northeastern, but maybe you can give us kind of the more complete picture. Can you take us kind of the Carla tour?
Well, I was born. No, we won't start there. I think one part of my story is really germane to why I'm doing the work that I'm doing now. And so I'll start there. I went to McGill University in 1981, and I love to read. So I decided to be an English major because I was going to get the job where I'm the one that works for the Book of the Month Club deciding what the book was, because my whole life would be reading books that were already pretty well ranked. And, that was a nice idea, but what I failed to recognize is I don't actually like to write about books. I just like to read them. So I changed my major to economics because it was more practical in my view. And then one of my roommates came home, and I'm of an age where when she suggested I would like computer science, she also threw a deck of computer cards down on the dining room table and with absolute disgust said, yuck, you would like computer science. I was like, what's that? And so in 1982, I took Fortran programming, and I kind of fell head over heels in love with problem solving. I have to say that it was an interesting day, the first day I walked into the lab. And for those of you who are listening to this that are of a certain age, I walked into a large lab that had terminals, VT100s. And I went to log on. It was my first programming assignment, and the screen went blank. And I didn't know what to do. And this woman came up to me and she said, "Oh, you didn't break it. Let me show you how to get that back." I think if she hadn't walked up to say that to me, I was super intimidated and I would have walked out the other way. After that semester, I was talking with my mother. It was the end of my second year, and I was deciding what I wanted to do. And she said, "Is there anything that makes you forget to eat?" My mother knows me well. And I said, "Yeah, when I'm writing code." And she goes, "Well, then you need to do that." So I did a major in
Little did she know that this is just a thing that happens to people when they code. They forget to sleep, they forget to eat. It doesn't, I guess you have to be pretty into it.
Absolutely.
But I think I hear that story way more with regard to programming than I do really any other subject. Like I don't hear chemists saying,
that's because you're a computer scientist.
Like I stayed up all night.
Come on. Like,
woodworkers are into it. Chemists are into it.
Okay. All right. Then I'll accept that. Please go on.
I think we call this confirmation bias. Anyway, so I switched my major to math, computer science, and then I went out and I worked. And then I thought, well, what's this AI thing? So I decided to get a master's, but I was cognizant enough of how you get funded as a grad student that I applied to the PhD program, even though I had absolutely no intention of getting a PhD. And then I took Paul Utgoff's machine learning class and just fell in love the same way I had fallen in love with computer science, because it put math and computer science together with solving real problems. So I decided to stay for a PhD, and Paul was my wonderful advisor.
So you tried to game the system, but the system gamed you. And now we got another computer scientist out of it. That's awesome.
Yeah. And then I was looking for a job after I finished, and I had a two-body opportunity. I hate the phrase two-body problem. I had a two-body opportunity that my kid's dad and I solved at Purdue, but I solved it by going to ECE, which was really, really a challenge. And actually it was called EE when I went there. And I remember having an anxiety dream. You know, how you have one about, you show up to the exam and, you haven't studied and it's the wrong exam. So my anxiety dream was that I was talking to the assistant head, and he said to me, "You're going to teach French." And I said, "I don't know French." And he goes, "No worries. You get 1 week ahead of the students. It'll all be fine." I said, "What about my accent?" And in the dream, he said, "They're from Indiana. It doesn't matter."
Wow.
Anyway, I was worried I'd have to teach something in electrical engineering. Right. It turned out it worked out really well, because it really cemented my desire to do applied machine learning. And I remember my last semester there, I was there for 10 years. My last semester there, I was teaching machine learning, and it was the largest graduate elective class in engineering, because it was really popular. And I had students from every part of engineering, and even people from food science and other parts of science. And it was the most fun class I ever taught, because I had somebody from everywhere. Then for family reasons, I needed to move back to Massachusetts. And I looked around at all of the schools, and I fell in love with Tufts and the medical school, and the atmosphere of Tufts is this one of giving back. And so it was just a wonderful place. And then I got recruited to be Dean of Computer Science at Northeastern. And my first reaction was, no, why would I want to do that? And then I thought about it a bit, and my husband has this wonderful saying that life's an amusement park. Why stay on the same carnival ride your whole life? I know, Michael, I've said that to you before when I've tried to recruit you. I'm sorry, you should probably delete that. And so I thought, well, I don't know, if I hate being dean, I'm sure Tufts will take me back. I don't have to give up tenure for the first year. But I ended up loving it, and I was able to do all of the work I wanted to do on changing the way computer science how people feel, how the access and belonging for all people feels. And we have amazing results at computer science at Northeastern. And now I'm going even further with that work and trying to do the work nationally.
That's great.
Well, okay, so I want to get into that a little bit more, but let me just throw in.
Yeah, I was just going to say, well, so I did my undergraduate at Tufts. So were you in Medford or were you downtown?
Well, I was in Medford for most of the time, but I had a joint appointment. They call it a secondary appointment there with the medical school. So I was there sometimes as well.
I see. Yeah. I mean, I thought Tufts was great. And if proper liberal education and absolutely the right spirit. So I was happy to see that on your resume and Northeastern. Okay. I'll take your word for it. But I needed to shout out for Tufts. So Michael, okay, go ahead.
Yes. Thanks. No, that's a cool connection. So I just wanted to say that I don't know. I think that within academia, within the professorhood or whatever you call it, there's not always a lot of respect for administrators and deans and chairs and whatnot. But it's obviously a very, very important job. And when it's done well, people can help see, they could see that, oh, wait, maybe this is a good thing. Maybe this is really important. And man, you were so good at that job. It was so remarkable to see that you just kind of turned yourself into this dean person and it's just remarkable at it. So it was just super cool because not everybody can make that transition. A lot of people don't even want to, but some people who do, they do it for whatever reason, the power trip or who knows what, but you were just great.
Well, I mean, it seems to me
someone asked me what the hardest part of being dean was. And I said, looking like the dean, having to wear a suit every day.
That's a lot. Yeah.
In Boston, other places you probably don't have to wear a suit every day, but Boston's very formal.
I mean, it seems to me that talking to people who have made this switch into administration is that, it's a way to have more leverage. It's a very different kind of task because now you're kind of operating on people rather than operating on physics or bits yourself directly, but you can have a big influence like that. And the people who I know, I'm thinking specifically of some of the people that were founding the School of Information in Michigan, and I asked them, how can you put up with all that bureaucracy? And they were like, well, if you love it, if you believe in the mission, then you're happy to get up and do the work every day. So I imagine that must have been your experience.
I think there's a huge difference in being a department chair and being a dean.
Yeah, School of
And I was a department chair at Tufts, and although I loved Tufts, I did not like the role of department chair. Your decisions are very local, they're very small, and you don't have the ability to raise money for the initiatives that you would like because chairs in most universities are not allowed to fundraise. Right. And my purpose in becoming a dean was really to work on diversity, equity, inclusion, access, and belonging, and to see if I had the ability to raise money and was in charge, could I materially move the representation, and not just in terms of numbers, but in terms of happiness as well.
Mm-hmm.
And so the dean of inclusive computing did that begin? Did you bring that to Northeastern? How did that go?
I did. So what happened is that we had done a lot of work at the undergraduate level. I'd also done the work at Tufts as well, and really moved the representation of populations that have been historically marginalized in tech, which includes women and races and minorities that have been historically marginalized in STEM in general. And one of the things that we did was create a new pathway for people to discover computer science called the Aligned Masters in Computer Science. And that's a master's for people who didn't study computer science as undergrads. So people would come in and they would do 2 semesters of basically undergraduate work, but not with the undergraduates because we had really, really intensive classes. So they learn about 2/3 of an undergraduate liberal arts computer science degree, and then they join the direct entry master's students to do a master's. And that program, we started with 11 students at our Seattle campus. We have graduated 550 students. We currently have over 1,200 enrolled, and it is 52% people who identify as women and 55% domestic students. And of the domestic students, we are at 21% races and ethnicities that have been historically marginalized in tech, which is way better than the national averages. And now we've started a consortium of universities that are offering the same program. Tracy Camp is running that consortium, but I still do a lot of the fundraising for it. And we've created a pathway for those students to then go to the PhD. Now, long story, one of our big gifts was from Pivotal Ventures, which is the investment and incubation nonprofit that Melinda French Gates created. And they called me up 2.5 years ago and said, we want to really double down after Melinda made the announcement that she was going to spend $1 billion on raising women up in various ways. One of them was in tech. And they asked me if I would be interested in running a center for inclusive computing, where I would work with other schools to help them materially move the needle on increasing the representation of population. And in particular, what Melinda was interested in was women of all races and ethnicities. And it was one of those moments where, it doesn't happen very often when you're my age, where your stomach just goes all squiggly because you can't believe you're going to have this opportunity. Wow. So I said, sure. And we wrote a proposal to them with McKinsey, where we, in a McKinsey fashion, and I'm very grateful to them, but we boiled the ocean, and then we drilled it down and put a proposal. And so I was doing that along with being dean. And it became clear to me about a little over a year ago, I couldn't be both dean of a college that had 6,000 students and run this center. And so I was going to have to choose. And so I decided that I would do this other thing because I would make a national impact. Right. And so now I'm running that full time. Now, where's my title from? I report to the provost. And I either had to be a senior vice provost or a dean to report to the provost. So they gave me a dean title. And I can only imagine what the new dean of Corey is going to think when they hear my title, because what are they, the dean of non-inclusive computing? Yeah. I'm sure it's going to be not popular. But what other, we couldn't think of a better title. So that's the one we came up with. And my boss, the provost, David Madigan, who you may know, Michael,
I didn't know that he had moved. That's awesome.
Yeah, he's our provost. He thought nobody would know what a senior vice provost is.
But extra dean is okay.
It'll be all right.
Yeah. Dean's a thing for sure.
Thing.
Well, and so, but the point is, just as you say, the scope is bigger than Northeastern, even though you're kind of based there. It's really trying to get this.
We're like a nonprofit inside of Northeastern,
right? And having teeny tiny microscopic experience in nonprofits, I can see a lot of value to have a big affiliation, to have a strong affiliation to an academic
environment. Get the space, all the services, my 9-month salary is covered. And I just have to, I mostly raise money that we then give to other schools to help them make systemic change, to remove the barriers.
Do you think there's a short list that's the secret sauce for this Align Masters? I mean, so it's a couple of sort of, I went to CMU, and when I started as a PhD student there, they have the immigration course. The first 6 weeks for each first year you meet every faculty member, and you have all of these older grad students teaching the younger grad students about the traditions and so on and so forth. And in fact, when I was deciding where to go for graduate school, I was scared to death. And the fact that CMU had this immigration course, this little bit of hand-holding, was like probably the reason I went there instead of going to Stanford, because Stanford was just sort of terrifying, like that. And so I wonder if the Align, that little intensive thing to funnel in, I would imagine that's one of the big keys. But what is the secret sauce to actually transferring and having other places increase underrepresented groups and women and so forth?
So first of all, Align is only one program. That's the master's level. The gift from Pivotal Ventures to work on increasing the number of women was for undergraduate programs. Oh. But let me answer your question about Align. The secret sauce there, a lot of it is in the recruiting. So we raised a lot of money to make the first semester free, because you know how when you're a computer scientist, you either fall in love or you don't. Right. We didn't want to add to student debt, particularly for people who might be first generation or might not come from economic privilege.
Wow, first semester free. That's great.
Mm-hmm. We also, the fact that they're a cohort, what's so fun on the first day is we ask the students what their undergraduate major is. And I've done a little work around the room to decide where I'm going to start. And I always want to start with my liberal arts students rather than my physicist or my EE. And about 1/3 of our students come from the liberal arts, 1/3 come from business, and the other third come from STEM. And we have over 100 different majors represented, but they're all there as a cohort. None of them have had computer science before. So that problem that you have in the intro sequence at the undergraduate level, where you've got some people who know a lot and some people who know nothing, and they don't feel good because the ones that know a lot show off, or don't even know they're showing off maybe. Yeah. And then we also have peer mentoring, and we also have something that we call the identity series, where we bring in people who had non-traditional pathways to talk about their road into computer science. And then we have more TA support. We have a math prep course for people to remember what log n is if it's been high school since they saw it. And so there's a lot of surrounding stuff that makes it work. And when they get to the master's program, we have actually done a study, and they tend to have higher grades than our direct entry students. And it is really hard to get into the direct entry program at Northeastern. I think we admit something like 15% of our applicants. Wow. We're really popular because of our co-op program. But what I'm doing now with the Center for Inclusive Computing is I'm working on the whole pipeline in universities. I do not work on K through 12. That's an important work to be done, but not my area of expertise. I'm working on helping undergraduate programs transform themselves, creating this consortium, and then we're also working on the PhD pipeline.
So, I mean, I would imagine that the thing like find the liberal arts person to talk to first, that does not make it into the 3-ring binder that other people can be trying to, or does it?
Yes, it does.
That's great.
So our consortium it's a network community of practice. And so we have monthly calls. And like I said, Tracy Camp is running this now. And one of the things we did recently was we brought in both students and advisors from the Northeastern program to talk about all of this surrounding stuff. We've also done a lot of fundraising to give universities some money to start their program with, because you need to buy out faculty time to be able to create the program. And we give all of our curriculum away as well.
Right. Well, that sounds super great. And then you're seeing traction. You're seeing these things are getting cloned, and those folks are having good retention and so forth.
Well, most of them are just starting. A few of them are a little more of the ways in, but a lot of them are just starting. And I mean, if you think about how many people get a master's in this country, and that we're now graduating about 600 students a year out of this program just at Northeastern. That's big.
Yeah, super.
Yeah, sort of.
And by the way, I should mention industry loves them, because if you think about it, right, if you're Fitbit and you hire a software engineer who also has a degree in sports management or nutrition, you've got like the perfect person to work for you.
And I mean, a lot at UNM, our master's program was mostly terminal. There was relatively little pipeline from the master's program into the PhD, although there were a few. And how does that play out in the Align or the people?
Interesting that you should ask that, because we just got NSF funding and funding from a private donor. to do something that we piloted at Northeastern with funding from Google, which was paying for people to have a research experience from this program. And so far at Northeastern, we ran the pilot in the last year. 7 of our students are now pursuing a PhD. And we don't care if they pursue it with us or someone else. We care that they go do a PhD program. And Google helped with mentoring and a lot of the support. And we are really excited that we have an NSF grant to do this, and also actually two philanthropists that are helping with that, and Google has re-upped as well. And this is really exciting. The program's called DREAM I can't think of it.
But it stands for something.
We talked about a lot of one. It's distributed something or other.
Great.
For the masters.
Distributed green.
Yeah. So I think that's important. I think it's important to think about that as a pathway, because the students that go through this master's program at any university are going to have more representation that's like our population than our undergraduate programs and than our traditional population does. And that's really exciting.
So the theme of our podcast is computing up, which I don't think any of us really knows what that means. But one thing that it could mean is this sort of notion that that computing is a fundamental building block for everything that people do. It has, depending on how you view it, it's always been true. But even modern computing, standard, what we think of as computing, is starting to have an impact across the board. So everybody, no matter what they do, computing is there someplace. Is that one of the things that's kind of driving you? Is that your vision for where computing? Like, can you tell us a little bit about how you see computing fitting into the world? Like, what is it? Is it like English or whatever, like writing, where like everybody just needs to know how to do it? Is it like math, where it's kind of the core thing in the sciences? Like, where does computing fit into the world?
I think it fits in everywhere. So the tagline that I created when I took over as dean of computer science at Northeastern was computer science for everyone. And it had 2 meanings. It meant that everyone should feel welcome. And it also meant that it applies to everything. So while I was there, we added what we call combined majors. Combined majors have been pejoratively called CS plus X at other places. We call them combined. And our combined majors have 9 courses from discipline 1, 9 courses from discipline 2, 1 or 2 integrative courses, and then a capstone that integrates the 2 together. And when I took over, this wasn't my idea. This was the previous dean, Larry Finkelstein's idea. And he created the idea so we wouldn't be reabsorbed by engineering, because it would be hard to reabsorb us. But he had combined with some of the more traditional parts, traditional ideas like physics, math, biology. I think he had biology, design. And what I did when I took over in 2014 was say, let's combine with the non-traditional stuff that have more gender and racial diversity than computer science. So now more than half of our majors are combined, and the gender diversity is way different. Overall, we're at 32% people who identify as female, but in the combined majors, we're at 39%. And our incoming class of first years this year was 46% people who identify as female. So our numbers are just steeply going up. And it's because of the combined majors, because we were able to tap in. And we didn't lean in admissions, because if one school leans in admissions, it just means the other schools lose out. So the whole thing we're trying to do at the center is create programs that women want to try, and that once they try, don't make them run screaming from the some of the stuff that happens at some of the universities.
That
so
seems like an appropriate
majors
bar.
are one way.
Got it. That makes a lot of sense. But in some sense, you're training people who are then professionally computer scientists, right?
They don't always go into computer science. Sometimes they take first of all, we have 3 undergraduate majors at Northeastern: cybersecurity, data science, and computer science. And they might go into the other field, but now they come in understanding tech. I'll give you an example of my own child who did theater and computer science. He really wants to do interactive media that really engages people, and think about how to put computer science into theater. So he did 2 work experience while he was at Northeastern. One, he worked for the artistic director of the Cambridge Theater, and the other, he worked for a company building apps during COVID. And now he wants to put those ideas together. So I don't know. I think there's more and more space for working at the juncture of 2 fields, and that we will see that increase. I should mention the other thing that I really focused on when I was at Northeastern was hiring interdisciplinary faculty. And about a third of the faculty have real cross-college appointments, cross-department appointments, where they teach in both, they do research in both, and then which one is their home college depends on who's going to tenure them. So if they don't do quantitative research, it always has to be the other place.
I mean, so Michael at Brown and Carla at Northeastern, I mean, has computer science made it into the undergraduate core? That was a fight that was happening at UNM.
So tricky, that gen ed requirement. That is the number one way that you can get people to try computer science. And in fact, that's what we did at Tufts. But we have a core where we have ideas. So there's thinking about data. So yes, our courses satisfy that one. And so do 200 other courses, right? Because the way the budget model works at a university, everybody wants to have something that satisfies the core requirements. So that one's hard, but that's one of the things we're working with. We through the Center for Inclusive Computing, we work with, we have both implementation grants and then data diagnostic grants. And our implementation grants are much bigger in quantity of how much money we give. And we also, provide technical advice. And one of the things we're really working with in a lot of schools is making computer science satisfy a gen ed requirement.
Right. Certainly that's a battle that UNM has had for quite some time. And I mean, geez, talking about Tufts University, in the late 70s at the Experimental College, which I hope still exists at Tufts, is a wonderful, wonderful program. I taught a class in DEC 10 assembly language in the Experimental College at Tufts, and we had a completely wacky bunch of people. It was wonderful. And so, I mean, I think, Michael, how about you? Does Brown have general education, computer science aspects?
The Brown philosophy is very open. So basically, there is a writing requirement at the university level, and you have to have a concentration. And that's it.
Can you write code?
There isn't anything like that.
No, you have to write English.
Oh, there's a writing requirement in English. That's right. There's no writing requirement in code. I think some people have said, hey, can I count my programming class as writing? And the university didn't bother to answer them because it was a silly question. But apart from that, yeah, it's just very open. And within the computer science department itself, we're now having debates about, well, do people have to have algorithms? Like they used to,
yeah,
or at least that was a requirement in the department. And then it went away for a long time. And now we're getting a lot of people graduating with very little in the way of technical computing. Not everybody. I mean, most people are doing things that look pretty traditional to me, but there's occasionally you can sort of play the requirements a little bit and take, a policy course and a history course and kind of count them as computing. And so now we're starting to worry. But computer science is in this interesting place now where it would be great for more people to get exposure and training. And not everybody has to be able to program an operating system or prove, NP completeness. But do we give those people degrees? So it sounds like maybe, Carla, you have a take on this.
Well, first of all, we did this combined degree. So our normal degree requires 14 computer science classes, and this one requires somewhere between 9 and 11, depending on where the integrative courses land. But we also created something that I named Meaningful Minors, where when you do a minor at Northeastern, it's 5 classes, and the first 2 are preordained. They're basically learning to program better with data structures. And then after that, depending on your major, your next 2 courses in computer science, we've taught our advisors and the advisors across the university what makes sense if you're in English, what makes sense if you're in biology. So an English major might take natural language understanding, and text mining or information retrieval. A design major might take data visualization and web design, and a bio major might take algorithms and machine learning. Then your fifth course, you can either take another course from the computer science college, or you can take one of 104 classes that we vetted that we are willing to call computer science. So like digital photography or network science. I did veto dystopian literatures as not relevant, even though it did fit the stereotype that
tech is bad.
English department had of what should count for a computer scientist.
Wait, so say again, this is in what context? This is either for
this is a minor, but
computer science.
This is a minor. This is someone who's taking English who decides to minor in computer science. They might take, introduction to programming, data structures, text mining, natural language understanding, and then one of the digital humanities courses, which is actually going to count for their regular major, for their English major. So we went and we looked at the whole course catalog.
Gotcha.
And then we had a committee vote on what we would count as something that would satisfy our minor. But the main thing here, the main idea is that the minor is customized to what your major interest is. Mm-hmm. And it's not a one size. Right. They don't need to take programming languages or compilers. If they're English majors, they need to take stuff related to their major.
Yeah, I see. So one thing I'm hearing is that the very existence of minors makes it so that you can actually get people the exposure that they want if they're not directly interested in computer science, and then the people who are directly interested in computer science, they can have the more intensive traditional experience, as it were.
Or they can do the combined major. So we have 57% of our students who are combined majors come in knowing they want to do that, and the rest add the second field. So they either come in as English and say, hey, this is really cool, I'm going to do data science in English, or they come in as computer science or cybersecurity and they say, hey, I'm going to add criminology to cybersecurity. So they add, and that's about even which way that goes.
I mean,
Gotcha.
You mentioned dystopian literature, and I mean, it does seem that these days in the zeitgeist, such as it is, there is a sort of big tech dystopian surveillance future that's out there as an idea. Do you think
maybe now Dave is relevant, but at the time, 7 years ago, I was like, I am not counting that as a computer science class. That's firmly over in the English degree.
And I'm sure that was the right call, but I was just trying to make a segue. So do you think that the computer science and engineering schools and the educational establishment apparatus, such it is, has an important role to play in helping shape the conversation about big tech, about privacy, about surveillance, and so forth? And if so, how does one shape that? What does that look like to you?
So I think it's really important to embed those topics throughout classes, not just in a standalone class. So two of our faculty, one in philosophy and one in computer science, got a grant from Mozilla to embed ethics and bias and all of those things inside of all of the classes, in addition to the standalone classes that we have on this. And in fact, this past year, we hired 3 faculty who are who are both in the philosophy department and in computer science. So they have a tenure home in philosophy, but they have either a 50% or a 25% appointment inside the Corey College of Computer Sciences at Northeastern to work on this exact problem. I think this is a huge and important and interesting area, both in philosophy and in computer science.
And I mean, I feel like the rise of cloud computing and the giant data centers and what people think of as big tech is, we kind of powered that. Computer science kind of made that possible. And so it kind of lands on us to some degree. Do you think? I mean, I don't know, maybe I'm too
I think it lands on humanity because I'm not sure all computer scientists can understand the ramifications of what they've created.
It doesn't mean they get a buy.
So I think I think that we should definitely work on it, but I think we should work on it with our colleagues who understand the societal implications and the policy decisions and the law. So we also have two people who are joint between law and computer science working on some of these issues.
Right.
Yeah. So I heard that as not that it doesn't fall on us so we can wash our hands of it. I heard it more as we have to make sure to engage other people because we can't do it alone. Right. We don't have the big picture to be able to solve these problems on our own. But, I think I agree with what Dave is getting at, which is that we have to find a way to meaningfully engage with these kinds of questions. So maybe as a kind of a parting question, Carla. So let's say that your deanship goes super well and you get schools all over the place paying more attention and following best practices with regard to diversity and inclusion issues. Like what does the world look like? What drives you to be working on this? What do you hope will come of all this?
Well, I hope that we have a better view of computer science for everyone, in the sense that what we invent for our population, which is very diverse, is invented by people who are representative of our entire population. I also think it's one there's an imperative with respect to who has the power in our country and who has the money. If you think about who has all the money right now, it's not representative of where our population is. And so we need to, the most lucrative job that you can get straight out of school right now is to be in tech. And once again, not everybody is fully invited there. And so I think that that's really, really important to me. If you think about someone who's first generation and who maybe, grew up in poverty, one family member getting a computer science degree can pull that whole family out of poverty. It means the siblings will be able to go to college and understand how to navigate college. There'll be the help. And I just think it's absolutely important that, I'm going to go out on a limb and say in some ways the American dream is a little broken, but not if you can get a tech degree.
Yeah, no, that's a good thought. I mean, UNM has a lot of, historically underrepresented undergrads and a lot of first generation undergrads, first in their family. And it's certainly, it feels like the best part of the job is helping people find that sort of stuff. And that seems really great. Carla, it just seems like you've been doing this sort of stuff basically your whole career. And that's really wonderful. And I would just say, from us, thank you. And thank you for coming to talk to us on Computing Up today.
Thank you. It was really fun, Michael, Dave. Thank you.
This was Computing Up. Thanks for listening.